Okay, other people on YouTube have gone over this topic pretty thoroughly, so I'm going to try to move through it pretty quickly. We're basically doing a video in honor of the upcoming equinox. Here we have a diagram generated by timeanddate.com. If you go to timeanddate.com and go to their sun and moon menu and come down to day and night map, you can generate one of these for pretty much any date you would like. And I picked this one out just as a fairly typical representation of what you would normally see. If we move on to the way the illumination pattern looks for the equinox, we see again the little symbol that represents the position on the Earth's surface where the sun would be directly overhead. We see again a representation of the point on the Earth's surface where the moon would be directly overhead. And we see what looks a lot like a rectangle. Now, this is just one possible projection of a map of the Earth's surface. It's not meant to represent the way the Earth actually exists physically. For good representations of the way the Earth is believed to physically exist, in the globe model, we would need a globe. And in the flat Earth model, we would need a map showing the flat Earth as the flat Earth model believes the Earth to exist. This is not it. So, moving on to a map that does show a pretty good representation of the way that the flat Earth model suggests that the Earth physically exists, we have again the pattern of illumination for a particular time on the equinox, which is coming up on September 22nd. We see the sun on the equator, as it should be, directly over a point in South America, as it should be, and illuminating half the planet, as it should. And everyone on a particular line of longitude is experiencing the same time and the same solar time simultaneously. On the map as shown, there's a line of longitude at the top of the map where everyone would simultaneously be experiencing sunrise, and a line of longitude running through the middle of Africa at the bottom of the map where everyone would simultaneously be experiencing sunset. This graphically illustrates as well that everywhere on the planet on that day you will experience 12 hours of daylight and 12 hours of night. I want to call some attention to that because it is, as far as I can tell, fairly commonly understood that there is a midnight sun phenomenon where you can go to Alaska in the summer and you will have many, many hours of daylight. In fact, if you go far enough north in Alaska, right near June 21st, you can find places where the sun will never set and will be above the horizon for 24 hours. Conversely, you can go to Alaska in the winter and the sun will never rise if you're far enough north. What fewer people seem to understand is that if you were to go to Alaska right now, you would get about 12 hours of daylight if you were out of every 24. If you were to go to Florida right now, you would get about 12 hours of daylight out of every 24. If you were to go to South America, about 12 hours. If you were to go to Antarctica, you would get about 12 hours. If you were to go to Australia, you would get about 12 hours of daylight out of every 24. This is the fun thing about the equinox. On that day, every place on the planet gets essentially the same number of hours of daylight. If you go to a really high elevation, like the top of Mount Everest, you can get a few extra minutes of daylight because the sunrise will appear to happen a few minutes early for you, and the sunset will happen a few minutes late. But this is a matter of a few minutes, relatively insignificant compared to the essentially 12 hours of light and darkness that you're getting on the equinox. This is part of the reason that I've shown the illumination map the way that I have. It could be argued that, well, maybe that's not the way the illumination actually happens. Maybe it isn't true that everyone on a given line of longitude experiences sunrise at the same moment. Maybe it isn't true that everyone on a given line of longitude experiences sunset at the same moment. It would be a pretty easy experiment to perform to check that. But the simple fact that I know from my own experience, near the equinox, you can travel very far north. I've been to Iceland near the equinox. You still get 12 hours of daylight and 12 hours of night. And you can travel very far south. I have friends who have traveled to New Zealand and lived in New Zealand on the equinox. You get 12 hours of daylight and 12 hours of night. Suggests that this pattern makes sense. If we move to a different illumination pattern like this one, I'm not going to spend any more time analyzing that, but if you imagine the sun moving at a constant rate around the equator, it's pretty hard to imagine how this illumination pattern is going to allow someone in Iceland, for instance, to experience the same amount of daylight in that 24-hour period as they experience darkness. It looks to me like they would be, with the sun moving at a steady rate, they would be in darkness much longer than they would be in sunlight. Now, to be nice, and I do think that's important, this doesn't disprove the flat Earth model. I would, however, be overjoyed if some people who are keen on the flat Earth model were to look at this and at least recognize that what they keep claiming is a very simple model of how the sun illuminates the Earth is not simple, and it is not straightforward. There may be explanations that could be given. I'm not going to argue it at the moment for how the sun manages to produce this illumination pattern on the equinox, but they don't seem straightforward to me. So my personal plea would be that the flat earthers could cut the rest of us a little slack and say, well, okay, based on phenomena like this one, where the pattern of illumination is clearly a bit odd, maybe we could cut the round earthers some slack and say, well, we can see why they don't immediately accept the flat earth model, because the flat earth model requires that the sun cast a path of illumination like this twice a year. That's not some freak occurrence that only happens once every 1,000 years. This is something that happens every 6 months, like clockwork. I'm going to cut myself off there. If you happen to have a bunch of friends who can line up along one of the lines of longitude, get them all together on a conference call. You can check to make sure that the sun comes up at the same time for all of them and goes down at the same time for all of them. If you don't have that many friends living at that many different latitudes, well, do the best that you can. My advice to everyone is keep experimenting and keep going out there and observing. Have fun.